As one of the authors of the Ilmakirja, I'm now going to present quite shortly the contents of the book. This book was published in Helsinki 2 years ago, and it was very soon sold out. And another edition came out maybe 1 month ago this year, so it's again available. And this tells that, or proves that, there is a growing interest in natural ventilation or natural stack effect ventilation in Finland among just common people as an alternative to mechanical ventilation. So why we wrote this book? It's the first kind of extensive book on natural stack effect ventilation in Finland. Although this system, just like Alois mentioned, was quite common, or it was the prevalent system in building in Finland until the 1950s, and even after that in individual buildings and terraced houses or row houses. And for example, I have lived almost all my life in a house that has natural stack effect ventilation. I'm still living in a house that was built in 1935. So, engineers are no longer being taught in Finland how to maintain or repair or plan and design natural ventilation. And this means that we have a very high level of knowledge and know-how in how to design mechanical ventilation. But there was a kind of ardent need for a book that would show how to maintain, repair, and design natural stack effect ventilation. And Julia and Leino have been part of teams that have been studying this in collaboration with the Ministry of Environment, etc., in earlier projects. And I came here, joined this project when we started to write this book. I'm an architect and a non-fiction writer. Julia is an architect, designer and restoration architect who is specialized in the issues of natural ventilation. And Leino is an engineer who is specializing in energy and ventilation issues. So I think we are a very good group. So we had some basic questions that we try to answer in this book. There are some here, and one of the kind of key issues for a designer and for an engineer who is designing natural ventilation is how to prove to the authorities that it's a system that can be used in modern buildings too. So we needed graphs, we needed engineering knowledge in this project. And of course, we couldn't do this all by ourselves. We needed a network of professionals who had in the different fields of building, who commented, gave advice, or told us where we went wrong in our writing. And then of course Leino and Julia, as they are designers, they are experienced in projects where you repair or design natural ventilation. Some basic issues about ventilation. What are the tasks? This is, well, it's the same applies to natural ventilation and mechanical ventilation. I think I don't need to go further into this issue, but to what we deal with in this book. We have different chapters devoted or dedicated to different topics, and first of all, how does the natural ventilation operate if it's designed as it should? And this is an issue that Julia will go deeper into in her presentation. But what is quite kind of the thing that I want to point out is that it's a passive system that doesn't need any external energy, but it works by the laws of nature. And to better understand how to maintain natural ventilation and how to improve it in existing buildings, we studied the history and evolution of the natural ventilation in Finland, and we could kind of recognize 4 different stages of it, starting from somewhere from the 18th century till today, or well, till the mid 20th century. Then there was a big gap in Finland, and very few buildings with natural ventilation were built. Then, of course, we had to kind of have a look at the regulations earlier. What were the requirements for ventilation earlier in Finnish buildings? Because they have kind of directed the planning of the floor plans and of the houses, and, of course, of the ventilation. What is important when we start to look at a certain building that has natural ventilation, or maybe problems that should be solved, is to investigate the system in this building. And we here give some advice how to do it and what must be taken into consideration. And then again, if you want to improve a system that is not working or operating properly, what can you do? Is it some smaller measures, or do you need kind of more extensive measures? And then the question of modern architecture. If you wish to design, for example, an individual house or a block of flats, how do you do it? You must start from the floor plan and in regard to the ideal placing of the flues or air ducts. So you cannot kind of just impose a natural ventilation system to any house. You must start from the floor plan, more or less. And then this is Leino's specialty, the graphs, how to dimension the airflows when designing or improving a natural ventilation system. And of course there are other ways to improve the indoor air quality, like plants inside. And for example, this is of course also an acute question. We should have more plants and trees out on the outside that give shade to buildings. As funny as it may sound, we all need some knowledge or information about how to use natural ventilation. This is an issue that I face in my house, because people don't know or understand the system, and we all often hear a criticism that, okay, it's natural ventilation, it just doesn't work, it's bad from the start. But you must know its limitations, and you must know its advantages, and then you can adjust it and you learn to live in that house. I must say that as I have always been living in a house with natural ventilation, I think it's the best. But that's my opinion. And of course, today it's quite important to take into consideration the issue of energy efficiency. And this is where Leino will give you some answers and maybe some questions, and you might have some discussion about it. It's a proved fact anyway in Finland that old solid brick buildings consume far less energy than theoretical calculations imply. And furthermore, these buildings, for example, these buildings in Helsinki, in the Töölö region, they have been constructed in a way that is sustainable and long-lived. And so is the ventilation system, natural ventilation system. And it's generally not worth adding short-lived technology to these houses. To end my speech, I'm showing a picture also from Töölö, which was a couple of years back. There was an article in some papers about this Adlon house built in 1939, which was called the low energy house of the 30s, because it the energy consumption was much lower than those average houses in Helsinki. So they have potentials, the old buildings. Thank you.